Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Examine the continuity of the function h of x equals mod of x plus 2 plus mod of x minus 1, right? So this is a sum of two mod functions, and let's write down what is our f of x and g of x, right? Because this seems to be a sum of two functions, and if you're going to call them f and g, what is our f and g, right? So let's write that out. F of x equals mod of x plus 2, right? And g of x equals mod of x minus 1, right? So both of them are mod functions, and therefore it calls for examining the continuity of any mod function, right? So let's do that and then come back to our f of x and g of x, right? So what is the mod function, right? Like if I'm going to call my function as mod of x plus a, right? And that a and x belong to r, right? Let me see if I can belong to r, right? So how do we rewrite this function? This function x plus a, and allow me to call it by, what do we call it as, say, z of x, right? We just picking up a general mod function which is mod of x plus a and x belong to r, and let's examine the continuity of this particular function, right? So a is a constant and z is a function that depends on x, right? So how do I rewrite this particular function? So if I rewrite this function based on the definition of mod, then this function equals x plus a for x plus a greater than or equal to 0, and then the same function is equal to minus of x plus a, right? Minus of x plus a whenever x a is lesser than 0, right? So I'm repeating it. So we're going back to the definition of mod function. And what is that? Mod of x plus a equals x plus a for x plus a greater than or equal to 0. And whenever my x plus a is lesser than 0, the function is rewritten as minus of x plus a, right? So what is my x plus a greater than or equal to 0? And allow me to rewrite this here. It is nothing but x greater than or equal to minus a, right? And what is my x plus a lesser than or equal to 0? So it is nothing but x is lesser than minus a, right? So now we have that this particular function takes two values. One is x plus a, which is applicable for all x greater than or equal to minus a, and the other is minus of x plus a for all x lesser than minus a, right? So now let's examine the continuity of the mod function from this angle, right? So let's pick up all x greater than minus a, right? So let me write this down in the next line. For all x greater than minus a, our function is x plus a, right? right? And I know that this is a simple linear polynomial of the form x plus a, right? So it is continuous for all x greater than minus a. I don't think we'll have to go into the detail. And now let's pick up r for all x lesser than minus a, right? What is our z of x, right? Our z of x is nothing but minus of x plus a, right? So let's write that as well. Z of x equals minus of x plus a. This is again a linear function. Again, we know that it is continuous for all x lesser than minus a, right? So for all x greater than minus a, let me highlight it in green. We know that the mod function is a continuous function. For all x lesser than minus a, we know that the mod function is a continuous function, right? Because it takes minus of x plus a, which is a linear function. So it is continuous for all x lesser than minus a. So what is that one point which is left for us to examine, right? Which is x equal to minus a. So x equal to minus a. And what is the definition of continuity, right? And I'm drawing your attention to the lesson that we saw in our previous video. For x to be continuous at x equals x naught, what is it? F of x naught, in this case f of x equals minus a, should be equal to the limit, right? So let us pull out limit, and that x tending to minus a plus, or x tending to minus a minus, right? Which is nothing but your, when I do a minus a plus h, what are we actually saying? I'm approaching minus a from the right hand side, right? And when we do a minus a minus, all that I'm doing is I'm approaching minus a from the left hand side. So it's nothing but my left hand or the right hand limit. Both will have to be equal, right? And what has to be that? That has to be my, this has to be my f of x, right? So I'm sorry, in this particular case, I just got this wrong, z of x. So because we're calling the mod function as z of x. So so at the point x equals minus a, what is my z of x, right? And let's work that out in the subsequent line. So let's pull out what is my z of x equals minus a. And what is that? It is this function, right? As we go back to the definition of mod, I'm just calling it by an yellow color. And what is that? When I substitute x equals minus a, I have minus a plus a, which is 0, right? So my z of x minus a is 0, right? So that is my step number one. And then I go and establish my limits, right? To further determine the continuity at the point x equals minus a. And for the limit, right, I pull out my LHL and my RHL, right? And what is that? So let's evaluate our RHL first. And what is my RHL? Remember, x tends to minus a plus h, right? So, and h is 0, is infinitesimal, and therefore tending to 0. And what do we have? In that particular case, I will have to apply this function still, right? The same function which we applied for x equals minus a, because as per mod definition, for x greater than or equal to minus a, we will have to apply the function x equals x, z of x equals x plus a, right? So when I do that, x plus a, and then I have minus a plus h. plus a, right? And what is that? My a and a gets cancelled, so I'm left with h, which is nothing but a 0, right? So let me write it in a rewrite this. So my h getting to 0, and this is my right hand limit, right? Let's go and evaluate our left hand limit and let's see what do we get, right? So I write my left hand limit. So my LHL is equal to, again, my limit of z of x. I'm going to write it like this and then come back and alter h, right? So let's do that. My x getting to minus a minus h, right? So minus a minus, and what is my z of x in that case? So now we know that when x takes a value which is minus a minus h, then it is lesser than minus a, right? So what is that? So I'll have to go back and pick up this function, right? Which is, let me call it in a different color. Let me call it, say, by a turquoise color. So I pull this out, and what is that? And I have minus of x plus a, nothing but minus of minus a minus h plus a, right? So again I have, my a gets cancelled and I'm left with a plus h, because minus into minus of h becomes plus h, which is nothing but 0, as h is infinitesimally small, and we can directly substitute it as h tending to 0, right? So we know that, so we've examined all the 3 points: x greater than or equal to minus a, x lesser than minus a, right? And yeah, so we had to do it in 3 parts. First, examine x greater than minus a. Next, we had to examine x lesser than minus a. And thirdly, the point where the function undergoes a change as we switch from uh, minus a minus h to minus a plus h, right? As we move from the left hand side of minus a to the right hand side of minus a, we will have to examine the continuity at the point a, at the point minus a. So we notice that the function is continuous because we have this condition satisfied. Let me call it again in uh, let me call it again in a different color, which is pink, right? And so let me call this by the turquoise, which is what happens when x less than minus a. And let me call this by the yellow color, right? So now we have that both of them, the left hand and the right hand limit, and at the point x equals minus a, all the three are 0, and therefore function is continuous at x equals minus a as well, right? So we have established continuity for x greater than minus a, lesser than minus a, and x equals minus a. So I don't see a discrepancy at any point for the mod function. The mod function is a continuous function, right? So I hope you understood why we started off this problem with mod of x plus a, right? Because this problem is a summation of two mod functions, and if we are able to generalize the mod function, calling it out as x plus a, mod of x plus a, and establish continuity, then it's going to be a lot more simpler to go ahead and solve this problem, right? So uh, when I go back to this problem, right, and let's go back to this problem, and let me, right, yeah. So we go back to the problem. We know that I'm going to call out whatever we just discussed is continuous at x belonging to R, right? Sorry, yeah, at x belonging to R, and therefore, what does it mean? X belonging to R, and therefore, what does it mean? The mod function is a continuous function for all of A, and A belonging to R as well, right? A is a constant and could be any real number, right? So A is a constant and it could be any real number. So now all that the problem becomes a lot simpler, right? So when I go back and look at what is my f of x, therefore my f of x is continuous at x belonging to R, and similarly my g of x, which is x minus 1 in this particular case, which is nothing but when I go back and do a substitution here, my a is nothing but minus 1, right? So otherwise you do not have to really worry about whether the a is positive or negative, and that was our original assumption in the uh, mm, previous case that we discussed when it comes to x plus a mod, right? So add again x belonging to R, right? So what does it mean? Therefore, h of x, back to h of x now, which is f plus g, is continuous because of the rule of algebra that we have. So therefore h of x equals f plus g is continuous at all x belonging to R. Again, drawing your attention to what we have on the right of your screen, which is nothing but the algebra of continuous functions, which is what we applied to solve this problem finally, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.